Okay, hi and welcome to Note 7.5. We're going to talk about linear inequalities. Linear inequalities have both an x and a y, or two variables as we'll say. But before we get too much into that, let's do a quick investigation. So the investigation asks us to graph this linear function right here, and it is a linear function, not an inequality. It's x plus 4, so y equals x plus 4. So if we graph that, I'm going to scroll down here. You can see here's the graph. I've already pre-picked some points. You can see some blue points and some green points. In the writings here, it goes ahead and asks us to find a couple of points and evaluate them. So first it says pick a couple that lie above the line, so we've done that. That's what these two blue points do. And it says evaluate and say algebraically what happens. So let's go ahead and plug these 2 points in, an x-coordinate and a y-coordinate, into that function. So y is 6, so 6, and we're going to use this inequality instead here, right? So 6 is greater than 0 plus 4. Well, what does that really mean? 6 is greater than 4? Yeah, that's true. So, hey, what does that mean? Well, I don't know. Let's check this other point and see if we can figure that out. So let's plug in 4 this time, or 3 for the y value. So y is 3, right? There's the y is 3, greater than negative 4 plus 4. So is 3 greater than negative 4 plus 4, which is 0? That's also true. So we find that the points above the line are telling us that the equation is true. It's making a true statement. But what does that really mean? Well, let's graph these other 2 points with the same equation and see what it says. So I picked the point 0, 0. Again, here's the green ones. These are below the line because that's what this says here. Pick some points that lie below the line. And let's plug them back into the same exact inequality. So 0 is greater than 0 plus 4. Again, just plugging in my x and my y there. So looking at that, it says 0 is greater than 4. Is that true? No, that's false. So let's plug in this other point that's also below the line. So negative 2 is greater than 6 plus 4. So saying negative 2 is greater than 10. That's also false. So what we find here is that if we graph points above the line, it's telling us that we got true statements. If we graph points below the line, they're telling us that it's false statements. What that means is that these are part of the solutions or the solution set. And the ones that are not part of the solution set. And we know with inequalities, if we were going to do anything with those, that the solution set always gets shaded, right? We draw the line towards it. We should be pretty used to that. So what that's kind of telling us is that any points that are going to lie above this line are going to be part of its solution set. And you're like, well, Mr. Hallam, this is a linear function. Well, now you can see the association between a linear function and a linear inequality. So really what it says is that if we can graph any linear function, we can graph any linear inequality. And it makes a line. The only difference is that we have to shade them appropriately to that inequality that's there. All right, I know I didn't do all of that, but let's jump to the real notes because there's a lot here. So let's jump down here and see if we can figure out some of this stuff. So let me line it up. There we go. All right. Okay, so in this section of notes, let's kind of get all of our understanding down for what an inequality, a linear inequality is, and what a solution looks like. What we know so far is that if we have one variable that we've seen, we graph those on number lines. And that's almost always true. There's a couple exceptions that we'll talk about, and that'll be horizontal and vertical linear inequalities. But for the majority of what we're going to spend our time with in this section of notes is that if we have two variables, then our inequality is some form of a line that has shading on it. And we graph those on coordinate planes. Okay, so that's where we're going to spend our time. That's where we're at right now. So let's talk about this. A linear inequality then describes a region of a coordinate plane that has a boundary. In this case, that's our line, okay, that we're going to graph. Excuse me. The solution of an inequality then is a set of points that make it true. Well, with this, since we have a line, a boundary, and some shading, there's a whole side of the line that will tell us that these are solutions. Sometimes the line can be part of that boundary, and sometimes the line's not. Let's see if we can break that down and figure it out. How do we do this? Well, one, we got a graph. So I don't care how you graph your boundary line, be it a table, be it from standard form, or be it from y-intercept form, but graph it. Use one of those 3 ways, whatever way works for you. That's great. Next, you got to decide if that line is a dashed line, which means that it's a less than or greater than sign, not included, or if it is included, that it's a solid line. So now you've got your line, now you've made it dashed or solid. Next, you got to decide which side of the line to graph, or shade. Which side we have to shade. So to shade that, or to do it, there's 2 possible ways. The way that kind of always works is a test point. Let me circle that a little bit bigger. You can use any test point, any integer number that you find on one side or the other, and you can pick as many as you want. Usually we pick 1 because it's the quickest, easiest way to decide. I tend to try to pick 0 if it's not on the line. If it's on the line, you don't want to pick 0, 0, right? So usually try 0, 0 because that makes things easier usually. And then test it, just like we saw on the investigation above. If it's true, we shade that side. If it's false, we shade the other side. That's what a test point says, right? True is shade this side. Let's write that down. True equals shade, and false equals shade other side. Okay, so now that we have that, there's one other technique that we can use if it's in slope-intercept form, where you have your y isolated all by itself. Then you can use this little trick here. I don't want to call it a trick, it's an association, shall we say. If you have y is less than, or again we like to say sometimes the solutions, okay, the solutions are less than, meaning you shade below the line. If it's y is greater than, then you're going to shade above the line. And that's what we'll try in this first example here. So let's scroll down here and see if we can put all that information into play. Let's just recap real quick. One, we're going to graph, right? So we're going to take this and graph it with our line with one of our techniques. We're going to decide if it's shaded or solid, or dashed or solid, second. And then third, we're going to decide which side to shade. So we got 3 parts that we have to do for this. So let's start with our graphing. So this is already in slope-intercept form, and 3 is our y-intercept. So I'm going to zoom in a little bit to make this easier to graph. I'm going to go up to 3. There's my point. So that's my first point. There's my y-intercept. Now I'm going to go ahead and use rise over run, 2 over 1. So I'm going to go up 2, right 1. I'm going to repeat this process a bunch of times so I get a nice line. Then I'm going to go to the opposite direction so I get a nice line as well. Down 2 over 1, down 2 over 1, down 2 over 1. Again, you guys are probably already really good at this. So now that we've got that, let's take a look at our inequality. Notice there's no included sign underneath, so we're going to say this is a dashed line. So we're going to make this dashed. That's a really big line, but it will work. So we get a dashed line there. So we graphed it like it was a linear inequality. We recognize that it was dashed. Let me go back to my blue. And now we have to decide which side to shade. Well, if you come back up here, again, y is less than, or again, say this as the solutions. Sometimes that helps me remember. The solutions are less than the line. This represents the line. This represents the solutions. So the solutions are less than the line, which means then I'm shading below. So I'm going to go over here. I'm going to grab this. I'm going to shade below the line. There's all the possible solutions. Let's talk about a particular case, though. If a point falls on the line, it is not, ooh, that's a really big one. Let's size that down a little bit. Maybe too big for what we need here. If it falls on this line, those are not solutions because the line is dashed. So any other point that I put anywhere over here, I can put a million of them if it lets me. Then these are all possible solutions. Anything below the line. Okay? Excellent. Let's do this one over here. In this particular case, it's in standard form. Does that mean anything different? No, it just means we're going to graph from standard form. And with standard form, you can change the form. There's nothing wrong with that. I'm going to go ahead and make my little table, right? For standard form, we find intercepts. So we're going to look for the x-intercept by knowing that y is 0, and the y-intercept is going to be where there's a 0 for the x-coordinate. So then I'm just going to plug these in, right? So this whole thing turns to 0. So 3x is, and when you find these intercepts, when you go to find these, it's probably easier if you change the inequality away because we're actually finding an x-coordinate, so it is equal to that value. It is not the same thing as graphing with this inequality. So I'm going to go ahead and find this out. So I'm going to divide by 3 on both sides. So x equals to 10/3 or 3 1/3, right? I'm going to plug that in. So my first coordinate point is 3 1/3. And I'm going to plug in 0 now for my x-coordinate, so that whole thing turns to 0. So I get negative 5y is equal to 10. Divide by negative 5, divide by negative 5 equals negative 2. So I get a negative 2 for my second coordinate. So there's my 2 points that I'm going to graph. Those are my intercepts. I'm going to graph my x-intercept first. I'm going to zoom in a little bit. I'm going to go to 3 1/3, so 3 and a little bit more, put a point. And then I'm going to go down to negative 2 and 0 and put a point. So there's my line. I'm going to check my inequality sign here. It's got an equal sign underneath, so I do have a nice solid bar. So I'm going to go ahead and grab this and try to shoot a line through there. There's my line. Now the next thing I have to do, because I've got my line, I've got my solid or dashed, I've got to decide which side is shaded. And you're like, Mr. Hallam, wait a minute, there's something with the Y. Yeah, this only works, this little technique that I showed you here, only works if we're in slope-intercept form. So if you decide to rather change these standard forms now, you're more than welcome to. But here's the second way. We did this inside of the investigation. You pick any test point. We said that, so let me change to red. I generally pick 0, 0. There it is. It's not on the line, so we're good. So pick 0, 0, check. Plug it into the inequality. 3x minus 5y is less than or equal to 10. Check. Plug 0 in there. Those both turn to 0. Is 0 less than or equal to 10? Yes, it's true. So we shade that side. So this side there, let me grab, I don't know, green. We shade the side that the point is true on. If it was false, we shade the other side. So does it matter if we don't pick the one that's true every time? No, you know which side to shade based off if it is true or false. So you don't have to pick another point. All right, so there's the gist of the notes. I'm going to leave the bottom one for classwork if you have some questions. It's filled out in the class notes. We'll take a look at it. It's a word problem, so maybe I'll bring that up in class and we'll talk about it there. But I don't want to make this too long, so I'm going to leave it here. If you have any questions, bring them to class and we'll see you there. All right, we'll talk to you later.